In this video, we're going to use the exponential growth and decay models to find values other than the resultant value. It says a virus takes 13 days to double its original population, A equals 2 A naught. How long will it take to triple its population? Round to the nearest tenth. So I'm going to put out here the exponential growth and decay model. And you can see P of 0 is the starting amount, P of t is the ending amount, K is the decay growth and rate, and T is the time. So let's kind of write down what all they give us, because we really have two problems. They give us the first problem, which they give us the time and what the populations were, where they have this A equals 2 A naught. So we can say that, in our case, that would be P of 0 is equal to, we don't really know, but for this problem it doesn't necessarily matter. P of t is actually just going to be 2 P of 0, which is why it doesn't matter, because this is actually equal to just double whatever that is. So the initial amount doesn't necessarily matter for this problem. And then our K, we do not know the decay rate, but we do know the time. And the time here, they tell us, is 13 days. So that's our first problem. Our second problem is we don't know P of 0, again, but again, it doesn't matter. We know P of t, that's going to be triple its population. So instead of double the population, 2 times P of 0, it'll be 3 times P of 0. We don't know the K value. But they want us to find this time value that we also don't know. So here's what we're going to do. We're going to find this K value for the first problem. We're going to plug it in here, and then we'll be able to find the time for the second problem. So let's start by solving problem 1. We're going to write 2 of P of 0, so 2 P of 0 for P of t is equal to P of 0, e to the K value, which we don't know, times 13, so that'd be 13K. Now I'm just going to divide out this variable, P of 0, on each side, and that's 2 equals e to the 13K. We're going to take the natural log on each side, so it's natural log of 2 equals natural log of e to the 13K. Our log laws tell us that natural log e is going to cancel, and 13K can be written in the front. So that's going to be natural log 2 equals 13K. Then we're going to divide by 13 on each side. And we have K equals, go ahead and plug this in the calculator. We have natural log 2 divided by 3 divided by 13, not 3. And we get a rate of 0.053. That's a growth rate because, of course, it's going up. It's doubling. It doubled in this situation. Now we're going to look at the triple piece. I will not use this 0.053 in the actual calculation to find the final answer. I'm just going to use the whole number that we have written here. But for my algebra purposes, I'll use 0.053 just so it's less writing. Let's go to solve problem 2. We can write that this is 0.053 now, and this is 0.053. So let's set the problem up for the second piece, and that would be 3. So they want us to triple the population, so that's 3 times the original population is going to equal the population e to the 0.053 t. I can divide the original population out, and that leaves 3 equals e to the 0.053 t. If I take the natural log of each side, I can use log laws to cancel the natural log e. Log base e of e is 1. This exponent comes to the front, so I have natural log of 3 equals 0.053 t. Divide by 0.053 on each side, and t is going to equal I'm going to use the whole number, remember here. So I'm going to say that natural log 3 is going to be divided by that whole number up there, so I'll just use the answer button. And that tells me the time is going to be 20.6, they say round to the nearest tenth, so it's 20.6 days to triple the virus.